Hi, here we are, page 5 of our unit circle packet. This is going to seem a little bit repetitive, but it's good review and it's important because this stuff isn't going to stick unless you see it multiple times. So what we're going to do today is we're going to extend our knowledge of the points that we found in number 3 and number 4 back on page 3, and we're going to plot the corresponding values in quadrants 2, 3, and 4. So we're going to take each of the 5 points, these guys, and we're going to reflect them over the y-axis, x-axis, and both axes. Essentially, we're going to create these points in all 4 quadrants, and we're going to have to assign proper signs, S-I-G-N-S, to the x and the y values as we move around the coordinate plane. So let me get this all cleaned up. You all put quadrant 1 in there. You can go back to page 3 and look at it, and then we're going to do the other 4 quadrants. When we move to quadrant 2, we're going to do exactly what we did in quadrant 1. We're going to plot our 5 points, and you need to make sure that you've got them in the right spots, and then we're going to connect them and put the points on them. Go ahead and do that for quadrant 2, quadrant 3, quadrant 4. This might take a little while, but again, it's going to reinforce these 30, 60, 90 and these 45, 45, 90 triangles that are actually hiding here, right, in the arcs of the circle. So go ahead, take a moment and do that. Go ahead and pause the video while you're working on that. Okay, when you finish, you should have something that looks like this, and what you have right now is a complete unit circle. This is going to be a tool that you use this year. You're going to use it in pre-calculus, you're going to use it in calculus. It's going to be really handy because it contains all kinds of shortcuts. And if you understand this is a 30-degree angle, this is a 45-degree angle, this is a 60-degree angle, this is a 90, and so forth, you can now use your 30, 60, 90, 45, 45, 90 triangles to get the trig ratios of any angle that is located along this unit circle, whether it be in quadrant 1, 2, 3, or 4. So this is a really powerful tool we've created. Before we move on, we're going to look at what is actually happening here, and we're going to draw just a little quadrant 1, and we're going to go back and revisit our right triangle. So if we have a point out here, and this is an x comma y point, and if we think about this as a circle, when we go to the right x and we go up y, this radius is the same as the hypotenuse. All right, and the radius is the square root of x squared plus y squared. Now, if you remember, your angle is always next to the origin. So if I want to calculate the sine of my theta, I now have a nice template to use that I can apply to any quadrant that I'm in. So that might make your y values positive or negative, or your x values positive or negative, depending on what quadrant you're in. So in general, the sine of theta is your y value divided by your hypotenuse, or your radius. Your cosine is going to be your x value, which is the adjacent to the angle side, over your radius, and your tangent is going to be your y divided by your x. So this becomes significant when we turn this radius into 1. When you're looking at the unit circle and all these lengths or distances from the origin become 1, now you can set your r equal to 1. So what happens is your sine of theta becomes just the y value in the unit circle. Your cosine theta becomes just the x value in the unit circle. And your tangent is your y value divided by your x value in the unit circle. And when we're talking about x and y values, what we're talking about are these points that we've located all along the unit circle. So when I ask what is the cosine of a 30-degree angle, we go to our 30-degree angle and we say, the cosines are the x values, so my cosine must be rad 3 over 2. If I want to know what the sine of a 90-degree angle is, now even though I don't have a triangle for 90 degrees, I know that the sine of a 90-degree angle would be the y value. So I look at the y value, and the y value is 1. This gives us a lot of information. All right, so when we connect all the dots with a compass, which I didn't do a compass, so my circle's a little bit squirrely, but we get a nice circle, and this happens to be a unit circle. And the reason this is a unit circle is because the radius equals 1. And why does this happen? It happens because the radius equals 1. We forced that to happen if you go back and look at your notes on page 3. Okay, now we're going to use this unit circle. This is going to be a task that you're going to want to complete with your group, but again, this repetition is intentional. I'm causing you to look at what you've learned, to think about it, and to use the information in a constructive way. So you're going to write in a very neat, organized manner, and you're going to list the angles that you see on your unit circle. I'm going to start with 0, and we're going to put the corresponding point that matches that. So 0 goes with the point 1, 0. And then the 30-degree angle goes with the point square root of 3 over 2, 1/2. Go ahead and do this for all of the angles on your unit circle. It's going to take a little while, but it's worth it because it's going to help you reinforce the idea of what's going on and how these things are all connected. You can pause the video now and then come back in a moment to check your answers. All right, that was a lot of work. I hope you feel okay. Let's just make sure we did this right, because you guys know me. Sometimes I have mistakes. Everything in quadrant 1, which goes up to 90, should be positive. So that's good. Everything in quadrant 2, the x values are all negative. That goes up to 180. Everything in quadrant 3, both x's and y's are negative. That's going to go to 270, so we're good. And then in quadrant 4, just the y values are negative. So I think we're good. It looks all right. And now we've already analyzed that the x value of the endpoint is the, and we're going back to this triangle up here, we said the x value is the cosine. The y value is the sine. All right, so that's what we're writing here. The x value of the endpoint is the cosine. And remember, this is a ratio. And the y value of the endpoint is the sine. And remember, this is a ratio. All right, so now if I say, what's the cosine of 270? You go to 270, you look at the x value, the cosine is 0. What's the sine of 45? You go to 45, the sine is the y value, sine of 45 is rad 2 over 2. What's the tangent of 90? Remember, the tangent is the y value divided by the x value. So if I go to 90 and I take y divided by x, that's 1 divided by 0, which is undefined. And some of you guys were asking me when we were doing page 2, why is the tangent of 90 undefined? That's why. All right, I hope this was illuminating. We're going to continue with this next class. You need to start working on your homework. Have a great weekend. I'll see you guys on Monday.